Hardness test. To perform the hardness test using the durometer, hold the tip firmly against the material for a few seconds. Then record the measurement. Repeat this measurement 3 times. The digital durometer type is used for soft rubbers and plastics, while the digital durometer type is for hard rubbers and hard thermoplastics/thermosets. Just to be sure, our group used both types of durometers and recorded the results. Using the digital durometer type, our mystery polymer recorded measurements were 67.3, 36.4, and 46.2, giving us an average of 50 and a standard deviation of 12.9. Using the digital durometer type, our mystery polymer recorded measurements were 57.3, 31.3, and 31.6, giving us an average of 50 and a standard deviation of 12.2.
Density test. To perform both the direct measurement density test and the water displacement test, first you need to measure and weigh the sample. Our sample's dimensions were length 90 mm, width 18 mm, thickness 3 mm. The mass of our sample was 4.4 grams. For our direct measurement density test, we used the volume equation of length by width by height and measured the volume of our sample to be 4,860 millimeters cubed. Using the density equation, our sample had a density of 905.35 kilograms per meters cubed. For our water displacement density test, we found that our sample floated on top of the water, indicating that its density was less than the density of the water. To complete the test, we placed a heavier item on top of our sample. The first step was to measure the volume of the heavier item, which was an odd-shaped eraser. The measurement beaker had 80 mils of water. The water displaced to 92 mils when the eraser was placed in the beaker. 92 mils minus 80 mils equals 12 mils of water, which converts to a volume of 12 centimeters cubed. The second step was to measure the volume of our sample by placing the eraser on top of the sample inside the beaker. The measurement beaker had 80 mils of water. The water displaced to 97 mils when the eraser was placed on top of the sample in the beaker. 97 minus 80 equals 17 mils of water. Subtracting the volume of the eraser from the measured volume gave our sample a water displacement of 5 mils and a volume of 5 centimeters cubed. Using the density equation, our sample had a density of 880 kilograms per meters cubed. The average measured density of our sample was 892.7 kilos per meters cubed, with a standard deviation of 12.7.
Tensile test. The tensile test will give us the tensile yield strength, ultimate yield strength, maximum elongation, and Young's modulus for our mystery polymer. To perform the test, first you need to know the dimensions of your sample. Sample 1 had a width of 7.24 millimeters and a thickness of 3 millimeters. Sample 2 had a width of 7.23 millimeters and a thickness of 2.97 millimeters. Sample 3 had a width of 7.27 millimeters and a thickness of 2.98 millimeters. The measurement length of each sample, a dot was marked at each end of the middle section, just after the curve. The tensile test machine then automatically measures the gauge length of the sample. Next, place the sample in the bottom grip of the universal load frame and tighten the grip. Then lower the top grip over the top of the sample and tighten the grip. Then place a very small amount of load on the sample to hold it in place. Before testing, we zero the load and the extension. Then we enter the sample dimensions that we measured earlier and then name the sample. Now we are ready to begin the test. The tensile test machine then slowly stretches the material until breaking point. Our 3 samples had an average offset yield strength of 33.75 MPa and a standard deviation of 0.3, an average ultimate tensile strength of 35.04 MPa with a standard deviation of 0.1, an average Young's modulus of 1.1 GPa with a standard deviation of 0.1, and an average maximum elongation of 61% strain with a standard deviation of 13.
Three-point bend test. The three-point bend test will give us the bending modulus, flexural stress and flexural strain for our mystery polymer. To perform the test, you need to know the dimensions of your sample. Sample 1 had a width of 18 millimeters and a thickness of 3 millimeters. Sample 2 had a width of 16 millimeters and a thickness of 3 millimeters. Sample 3 had a width of 16.09 millimeters and a thickness of 2.94 millimeters. We then place our sample on the two support pins, which are 50 millimeters apart, making sure to keep the central loading pin in the middle. Next, we lower the central loading pin until it touches the sample to hold it in place. Before testing, we zero the load and the extension. Then we enter the sample dimensions that we measured earlier and then name the sample. Now we are ready to begin the test. The three-point bend test slowly bends the sample up to a predetermined point, and then the test is stopped. Our three samples had an average flexural modulus of 137.4 GPa with a standard deviation of 11.9, an average 5% strain limit of 60.12 MPa with a standard deviation of 0.6, and an average ultimate flexural strength of 62.09 MPa with a standard deviation of 0.8.
Our material identification. Using the CES Material Level 3 database, we have identified the mystery polymer to be polypropylene impact copolymer flame retarded HB.